Hello and welcome to Edusati. Let's discuss the topic of number system. We'll start with number chart, followed by BODMAS rule. Then we'll look at properties of certain numbers, followed by their divisibility rules, concept of factors, multiples and factorization, followed by HCF, LCM and their applications. Then we'll look at the concept of cyclicity and we'll end it with the concept of remainders and some important theorems related to remainders. So, let's get started and look at the first thing, which is the number chart. Numbers can be divided into two categories. Real numbers. Real numbers are the numbers that can be represented on the number line. Now, if you remember what is a number line is a line that extends from minus infinity to plus infinity and has 0 in the middle. This line is called as number line. So any number that can be represented on this number line is known as real number. And imaginary numbers. The numbers that cannot be represented on the real number line are known as imaginary numbers. Now if you have to look at it in a point of view, square root of a negative number is not possible. So if I say find out the square root of 4, you will say the answer is plus minus 2. But what is the square root of minus 4? It is not plus minus 2. It can be written as 2 into square root of minus 1. This square root of minus 1 is a term which refers to iota and is an imaginary number. So square roots or cube roots or any root, nth root of a negative number is not possible. Such a number is known as imaginary number. So a number could be a real number or an imaginary number. These are the two broad classification of numbers. Let's talk about real numbers now. Real numbers. Real numbers, as I already stated, can be represented on the number line extending from minus infinity to plus infinity. So that means real number can be negative and can be positive. So you can have negative real numbers, you can have positive real number, and the case of 0. Let's look at how real numbers can be classified. The first classification will be rational numbers. Any number that can be expressed in the form p by q, where the denominator, which is q, is not equal to 0, is known as a rational number. So any number that can be written in the form p by q, so that means a number 2, a number 3 by 2, a number 1 by 2, a number which is 100 by 7 or 7 by 100, anything that can be represented in the form of p by q, where q is not equal to 0, because if q becomes equal to 0, the number will be an undefined number. And irrational numbers. Irrational number, a number which cannot be represented in the form of p by q. That means a number which cannot be represented in the form of numerator over denominator is an irrational number. That is the definition. But if you go by understanding, irrational numbers are the numbers which are non-terminating and non-repeating decimals. So if a number is non-terminating, that means it does not end, and non-repeating, that means there is no pattern which is formed once the number is written. Such kind of numbers, it is very difficult, or I would say it is impossible for a non-terminating and non-repeating number to be written in the form of p by q. Such numbers would be known as irrational numbers. A point to notice, it is non-terminating and non-repeating. It is not non-terminating or non-repeating. Both the conditions have to be satisfied. Some examples of these kinds of numbers are pi. Pi is what? 3.14, and it goes on and on and on and on. It cannot be written in the form p by q. Now if you say pi is written as 22 by 7, that is just an approximation. That is not the exact value of pi, because if you keep on solving 3.14 and all that kind of stuff, it goes on to give you a non-terminating and non-repeating decimal. The other example could be square root of 3 or square root of 5 or square root of 2. The value goes on and it gives you a form which is non-terminating and non-repeating. So real numbers can be classified into rational or irrational. Any number that can be represented in the form p by q or numerator or denominator is known as a rational number. A number which cannot be represented in the form of p by q, examples are pi, square root of 2, square root of 3, or any root of a natural number where the exact root is not possible is an example of irrational numbers. Irrational numbers are non-repeating and non-terminating. Let's look at the case of rational numbers closely now. I already stated rational number is a number that can be expressed in the form p by q, where p and q are integers. This rational number can be again classified into integers and fraction. Integers. Integer means that if I make the denominator q equals to 1, I'll only have the case of numerator such as 2, 5, 100, minus 10, or it can be minus 73, whatever. I have my denominator equals to 1. That is known as integer. So an integer is a number whose fractional part is 0. I have only the integer part. There is no fractional part associated with the number. There is no decimal associated with the number. So if I do not have a fractional part, I would call it as an integer. If I have a fractional part, I will call it as a fractional. So where if my q is not equal to 1, obviously q cannot be equal to 0, and p is not a multiple of q. Now what does that mean? P cannot be cancelled out with q to give me an integer. That is a fraction. So what is it? 2 by 7, 5 by 7, 7 by 11. So I have numerator over denominator form where denominator is not equal to 0 is an example of a fraction. Rational numbers, integers and fraction. Real numbers, rational and irrational. Let's look at fractions now. Fractions could be terminating and non-repeating. Terminating means it ends, and non-repeating means it terminates but it does not repeat. So for example, 1 by 4, what is it? 0.25. 1 by 8, 0.125. These are the decimals, or these are the fractions that terminate. That means they have an end. They do not form non-terminating, non-repeating. Had they been the case of non-terminating and non-repeating, I would have called them as irrational numbers. So if you have fractional, they would definitely terminate. The second could be non-terminating but repeating. So I can have non-terminating but they are repeating. See, look, both the things need not be satisfied, because if both the things are satisfied, it will turn into an irrational number. So here it is non-terminating but it is repeating. Something like 1 by 3, it is 0.3333. 1 by 7. So if you go on solving these kind of questions, 0.1428, 1428, 1428, and it goes on. So these are the examples of fractions that you can have. Let's look at integers in detail. Integers. They are real numbers having no decimal. So that means if I have fixed the number p by q form and I have fixed the denominator equal to 1, I get an integer. So the examples could be negative integers or positive integers and the case of 0. So integers can be classified as negative integers extending from minus infinity till the case of minus 1. It will have a case of positive integers, or I would say as non-negative integers. Non-negative integers means non-negative means 0 and positive. Now 0 is neither negative nor positive. So 0 will not come in the negative category, 0 will not come in the positive category. But when I'm saying non-negative, that means non-negative. They should not be negative. They can be 0 or they can be positive. So non-negative will start from the case of 0 and extend till plus infinity. They'll go on till the case of plus infinity. So if I have to classify them, I would call them as 0, which is neutral, and positive. Positive natural number, positive integers would start from 1 and go on till plus infinity. The other name for positive integer is natural number. So natural numbers, they start from 1 and they go on till infinity. The other name for non-negative integers is whole numbers. Whole numbers start from 0 and extend up to plus infinity. So natural numbers is a subset of whole numbers. Whole numbers start from 0, natural numbers start from 1. 0 is neither negative nor positive. So 0 would not be covered in negative integers, 0 would not be covered in positive integers, but 0 would be covered when we are talking about the case of non-negative integers. That means non-negative can be the case of 0 or positive. Let's move ahead and let's look at integers in another way. Integers can be classified as even or odd. Even, any number that can be represented in the form of 2n, where n is an integer, is an even number. An even number is a multiple of 2. It can be represented in the form of 2n. Or in another way, the remainder of this number, the remainder which an even number gives when a number is divided by 2 comes out to be 0. So if a number when divided by 2 gives a remainder of 0, it will be an even number. Odd number, it can be expressed in the form of 2n plus 1 or 2n minus 1. That means when divided with 2, I get a remainder of plus 1 or minus 1. That means the number is not a multiple of 2. It is some odd number which gives me a remainder of plus or minus 1 when divided by 2. So integers can be classified as even or odd. Minus 3, minus 1, all of them will be odd integers, and minus 4, minus 2, plus 4, all of them would be categorized as even integers. So let's look at some of the rules that we have. If you have two odd integers and you are adding them, you would get an even. So for example, 5 plus 3 adds up to give you even. Even if you are subtracting two odd integers, you get an even. If you are subtracting just like yeah. So when you are subtracting, you get an even integer as your answer. Odd, I would write it as something like 2n1 plus 1, and the second one I write it as 2n2 plus 1. So when I combine, I can write it as 2n1 plus n2 plus 2. So this remainder which is there gets added up to give you 2, which can be combined with the initial quotients that you have to give you a newer quotient, and there's no remainder that you have. So you get an even number. Even and even adds up to give you even. Odd and even, there's a remainder of 1, there's a remainder of 0. So if you add up, remainder of 1 will still be there to give you a number which is odd. Odd into odd will give you again an odd number. Even into even would again give you an even number, and even into anything, let it be an even or an odd, will still give you an even answer. Even into anything, let it be even or odd, will always give you an even answer. Only odd into odd will give you odd answer. Otherwise, odd into even or even into even will end up giving you an answer which turns out to be even. That means a multiple of 2. Let's look at the case of positive integers now, or natural numbers. Natural numbers can be classified as prime, composite, or unity. Now when I'm talking about this, prime number is a number which is having two distinct factors. So the number of factors for a prime number has to be 2, exactly 2. First prime factor is 1, and the second prime factor is the number itself. That means a prime number is only divisible. A prime number is only divisible by 1 and itself. Prime number is not divisible by others number. It is only divisible by 1 and itself. Examples are 2, 3, 5, 7, 11, 13, 17, 19 and so on. All the numbers which are only divisible by two numbers, 1 and the number itself, are known as prime numbers. Numbers which have more than 2 factors. So other than prime, I can say a number which has more than 2 factors. So that means the minimum number of factors for a composite number has to be 3. So minimum has to be 3. Would be known as composite numbers. A number which is not a prime number generally is a composite number with an exception of unity. 1. It is neither prime nor composite, because for prime you need to have 2 factors and for composite you need to have greater than 2 factors, and the number which is 1 has only one factor, which is 1. So it is neither prime nor composite. Natural numbers, again if I talk about prime or composite with an exception of unity. Unity is not a composite number. So the smallest prime number that you have is 2. And it is the only even prime number. All the other prime numbers that you have are odd. It is the only even prime number. So if you talk about all the other prime numbers, 3, 5, 7, 11, 13, they have to be odd, because if they turn out to be even, they will be divisible by 1, 2 and the number itself. So it will turn out to be a composite number. Let's move ahead and let's look at some of the properties of prime numbers. Prime number has 2 factors with an exception of 1. 1 is neither prime nor composite, as I already stated. 2 is the only even prime number that you have. All the other prime numbers are odd. All the prime numbers greater than 3 are of the form 6n plus minus 1. So all the prime numbers greater than 3, that means I will start from the prime number which is 5. When they are divided by 6, they either leave a remainder of plus 1 or minus 1. That means every prime number when divided by 6, so if I look at a prime number divided by 6 and I look at the remainder would always be 1 or 5. I will write 5 as minus 1. We'll understand it when we'll move ahead in the presentation, that what is the concept of negative remainders. So every prime number, if you look at a number 7, it is giving you a remainder of 1. You look at a number 11, it is giving you a remainder of 5. You look at a number which is 13, giving you a remainder of 1. Look at a number 17, giving you a remainder of 5. Look at a number 19, giving you a remainder of 1, and so on. So all the prime numbers when divided by 6 would give a remainder of either plus 1 or minus 1. So I would write it as plus 1 or minus 5. But the reverse is not true. So every number following this rule will not be a prime number. But every prime number follows this. For example, you look at an example which is 35. 35 when divided by 6 will give me a remainder of plus 5 or minus 1. And I clearly know 35 is not a prime number because 35 is divisible by all of these numbers. 1, 5, 7, 35, all of them. So 35 is not a prime number, but it is still following it. So how do we do it? It's a one-way statement. All the prime numbers follow it, but all the numbers following it are not prime numbers. There are infinite set of twin prime. Twin prime. What is twin prime? If a pair of prime numbers differ by 2. So that means if the difference between two consecutive prime numbers turns out to be 2, such prime numbers are known as twin prime, and there are infinite sets of such twin prime numbers that you have. 17, 19, then it will go on, and there are infinite sets that you have. There is exactly one set of prime triplets, n, n plus 2 and n plus 4. We've talked about twin prime, that means the difference between the two prime number has to be 2. Now if I talk about 3 such number where the difference has to be 2, there's only one set, exactly one set of prime numbers which follow this rule, which is 2, which is 3, 5 and 7. So there's one exactly set of prime triplets which would be a case of twin primes in both the cases. 2p minus 1 is always a prime number where P is a prime number and is known as Meson's prime. So 2 raised to power anything minus 1 is always a prime number. So 2 cube, which is 8, minus 1, 7. 2 raised to power 4, if I look at it. 2 raised to power 4 cannot be taken here because this power has to be a prime power. That has to be for 2. So if I look at 2 raised to power 5 minus 1, which is what? 31. 2 raised to power 6. I can't take 6 because 6 is not a prime number. So if I look at 2 raised to power 7 minus 1, it is 127. It is again a prime number. So if I have to look at it, 2 raised to power any prime number minus 1 would always give me a prime number. I have given you a number. You have to tell me if the given number is a prime number or not. You can't divide it with 6 and look at the remainder plus minus 1 because it is not a short way of solving it out. We have already taken example of 35, which when divided with 6 gives a remainder of plus 5, yet was not a prime number. So how do we check it? Let's look at it. A prime number is not divisible by any number below its square root. I know this thing that a prime number is only divisible by 1 and the number itself. If I just extend this thing, I will also realize that a prime number is not divisible. It is not by any other prime number below its square root. If it is divisible, it will not be a prime number. It is not divisible. So what I do is, I find out the approximate square root of the given number. Divide this with all the prime numbers below its square root. So whatever the number that I've given you, I will divide this with all the prime numbers below the square root. Sorry, this is with. Divide this with all the prime numbers below its square root. If it is divisible by any prime number below its square root, it is not a prime number. If it is not divisible by any number below its square root, the given number is a prime number. Let's understand it with the help of an example. The question is 179 a prime number? I'll take the approximate square root of 179, which turns out to be 13.3. I don't need the exact square root. I can just work out with 13 point something. I just know 179 is 13 point something. I will check the divisibility of 179 with all the prime numbers below 13. So what are the prime numbers below 13? There will be 2, 3, 5, 7, 11, and I'll also check it with 13 because the value that I was getting was coming out to be 13 point something. So if I check the divisibility of 179 with 2, it is not divisible. I'll check the divisibility of 179 with 3, again not divisible. With 5, not divisible. I will just check with 7, 11 and 13. If it is not divisible by any, it is a prime number that we have. So I will not go on checking till 179 with all the prime numbers. I'll only check it below the square root. Because if it's not divisible by any other prime number below its square root, it will not be divisible by any prime number or any other number above its square root as well. That is the concept of factors, which we'll understand as we move on in the presentation. So, if I just look at it, prime number has two factors, one and the number itself. It is not divisible by any other number below its square root. So, I find out the approximate square root and I try to divide the number with all the prime numbers below its approximate square root. If it is not divisible, it is a prime number. That is a way to calculate whether the given number is a prime number or not. However, for a preliminary step, I can divide it with 6 and look at the remainder as well. If when divided with 6, the remainder is not equal to +1 or +5, I need not perform this step. If the remainder is coming out to be 2, 3, 4, I will not even look at this step. This is an exact method to follow. So I can eliminate some of the options by the basic rule, which is divisibility with 6, and then look at the short method of finding out whether a given number is a prime number or not. Let's move ahead And let's look at coprime numbers. Now what are coprime numbers? Prime you understand. What is coprime? Two numbers, I need to have minimum of two numbers whose HCF is 1. That means whose highest common factor is 1 are known as coprime. That means they have nothing in common except 1. So I find out the factors for both the numbers. If except 1 there is no other common factor, the numbers are known as coprime numbers. For example, let's look at the case of 4 and 9. 4 and 9, 4. If I look at 4, the factors of 4 are 1, 2 and 4. 4 is divisible by 1, 4 is divisible by 2, 4 is divisible by 4. Let's look at 9. 9 is divisible by 1, by 3 and by 9. Now if I look at the common factors that we have, they have no other common factor except the case of 1. Such numbers are known as coprime numbers. So minimum numbers that I need to check will be 2. I can check any more numbers depending upon their HCF. HCF stands for highest common factor. So their highest common factor has to be 1. It's the case of highest common factor. Let's look at example where we are converting a recurring decimal into fractions. Now if you remember, when we did the case of irrational numbers, we talked about non-repeating and non-terminating. And we classified repeating and terminating as fractions. We classified terminating but non-repeating as fractions. So let's look at the case how a recurring decimal can be converted into a fractional form or in a p by q form, wherein recurring decimal is also a case of rational numbers. So let's look at the example that we had. We are talking about this value 12454545. Now look at it. 454545 is a repeating pattern that we have, which goes on till infinity. So I'll start the question by putting x is equal to 0.12454545. I'll put a bar over the repeating decimal. This bar represents that this number goes on till infinity. Now the first step that you have to do, the step 1 that you have to do is bring the non-repeating part in front of the decimal. So I'll multiply this number with 100 on both the sides and I'll get 12.45 bar. This is my step 1. After the decimal, I should only have repeating part. I should have no non-repeating digits after the decimal. Now step 2. Bring the repeating part once in front of decimal. So this 45 has to be brought in front of the decimal. So that means I'll multiply with 100 again and I'll have my answer as this. Now after the decimal sign, I'm writing again 45 bar because this goes on till infinity. So if from infinity, even if I take out 1, it does not make any difference to infinity. It can be still written as 1245.45 bar. Now I'll take this as the first equation and I'll take this as the second equation. I will subtract 1 from 2 and I will look at the case where I'll get my result. So this is 10,000 x minus 100x equals to 1245.45 bar minus 12.45. Now while I do this, after the decimal part, the things become 0, 0. So I'm only left with the numbers before the decimal, which will be 1233, and here I have 9900x. So the value of x is 1233 over 9900. X was this, so that means this has been written in a fractional form and is equivalent of 1233 over 9900, which is what? P by Q form, and Q is not equal to 0. This is how we can convert a recurring decimal into a fraction. Now if you have to do it in a shortcut, we do it like this. the numerator is the entire number written as such. This is the entire number written as such once all the digits. Minus the non-repeating part, which is what? 12 over the number of 9s equal to the number of repeating digits. Now here I had two repeating digits, 4 and 5. So the number of 9s will be equal to the number of repeating digits, followed by the number of zeros equal to the non-repeating digits. Well, how many non-repeating digits I had? 1, 2. So there were two non-repeating digits, so I'll just use them and my answer will be 1233 over 9900. I'll get it in one go. I hope you've understood the process. It's very, very simple. Let's look at some of the questions related to this. So this is a CAT 2000 question. The question is, what should be the value of point AB, AB, AB? So this is what? This is a recurring decimal that I have. I'll write it as AB bar, where A and B are single digit whole numbers with both A and B not being 0 simultaneously. So A could be 0, B non-zero, B could be 0, A non-zero, but both of them cannot be 0 simultaneously, otherwise it will become 0. Be multiplied to get an integral value. So if I have to just do this, how will I write? If I have to write it in a fractional form, x will be equal to the number as such, right, over the number of 9s equal to the non-repeating digits. Equal to the repeating digits. There are two repeating digits, so I'll get this. If you have to actually understood this, I'll multiply x with 100 and I'll get AB dot AB. I will subtract, this will be my 2 equation, this will be my 1, I'll subtract 1 from 2, so I'll get 99x equal to AB and x is equal to this. Now, if I multiply this number with any number which is 99 multiple, 99, 198 and so on, I will get an integral value. Integral value means the denominator will get cancelled out and I'll only be left with the numerator part. So look at it. If I multiply it with 198, that 99 would get cancelled out and my total answer would be 2AB, which is an integer. So this question was very, very simple. Now if you have to take it with an example, you can take x is equal to 0.23 or x is equal to 0.30 bar or x is equal to 0.03 bar. So this will be 030303. In all of these cases, I will have 23 over 99. I'll have 30 over 99 and I'll have 03 over 99 as my fraction form. Let's look at another example that we have. This was a question that came in CAT 2001. Let x, y and z are distinct integers. So that means x, y and z cannot be the same. X and y are odd and positive while z is even and positive. Now whenever you have a question of this type and you have to tell me which of the following statements cannot be true. Cannot means that statement has to be false under each and every situation which has been given to you. It cannot be true even under one situation which is there. So let's look at it and how we'll proceed with the question. Now for this thing, you can take the value of x as 3, the value of y as 5 and the value of z as 2. So it's the simplest ways, imagine the values or assume the values and solve the question. Now let's look at the first, x minus z whole square. So if you do 3 minus 2 whole square, what is it? 1 whole square is 1 into 5. 1 into 5, it is coming out to be 5, which is odd, is even. This is a statement which is not true. Cannot be true. That means it cannot be, it has to be false. It has to be false even under one circumstance. Let's look at the next one. X minus z. Again, this is 1 into y square. Y is odd. So y square 25 is odd. This is true. Third, x minus z. X minus z, which is again 1 into y is odd into 5, which is, this is also correct. Last one, x minus y. So this will be 3 minus 5, which is minus 2 whole square. This is 4 into 2. It is even. This is true because z is even. So even this is odd or even, this will always turn out to be even. So the statement which cannot be true is the first statement because it is coming out to be odd in the case where I have assumed x is equal to 3, z is equal to 2 and y is equal to 5. Let's look at digit sum of a number. Digit sum represents a single digit obtained by adding the digits of a number. So if I give you a number which is 458, what I'll do is I'll add up all the digits. So 4 plus 5 plus 8. I get 17. This is not a single digit number. This is still a 2-digit number. So I'll keep on adding the digits of the number till the time I get a single digit. The single digit that has been obtained in this case comes out to be 8. Now, if I look at the digit sum, it can always be expressed as 9w plus d. 9 means when divided with 9, it can be represented as 9 into a whole number plus a digit. This digit is basically the remainder with 9. So if I look at 8, 8 when divided by 9 can be written as what? 8 is not divisible by 9, so the remainder is 0. So 9 into 0 plus 9. So the value here for w comes out to be 0, and the value of this digit, 8, this d comes out to be 8. Perfect square. A number is a perfect square that can be expressed as a product of two equal integers. So if a number can be expressed as a product of two equal integers, that kind of a number is known as a perfect square. So if I look at the case of 4, what is it? 2 into 2, 9, 3 into 3. So 16, 4 into 4, 25, 5 into 5. All these numbers which can be expressed as a product of two equal integers is known as a perfect square. Unit digit of a perfect square can be 0, 1, 4, 5, 6 and 9. For a perfect square, it cannot end with 2, 3, 7 or 8. A perfect square cannot end with 2, 3, 7 or 8. It has to only end with 0, 1, 4, 5, 6 and 9. Digit sum of any perfect square. Now digit sum is something that we've just learned now. That means I sum up all the digits till the time I get a single digit number. For a perfect square has to be 1, 4, 9 or 7. Digit sum of any perfect square has to assume one out of these four values, 1, 4, 9 and 7. N plus 1 whole square. Now if you look at it, this is a perfect number. N plus 1 whole square can be written as, I can open the thing, n square plus 1 square plus 2n, n square plus 2n plus 1. So if you look at it, this is the relationship between the squares of two consecutive numbers. So if you know the value of n squared, the value of n plus 1 squared would be n square plus 2n plus 1. So if you look at it, if n square is even, this will come out to be, n plus 1 square will come out to be odd. If n square is odd, n plus 1 whole square would come out to be even. A perfect square has always odd number of factors. Now this is a very, very important thing that we have when we are looking at perfect squares. The number of factors, if we calculate for a perfect square, always comes out to be odd. For other numbers which are not perfect squares, the number of factors would come out to be even. Perfect square has odd number of factors always. Let's look at perfect number now. Perfect square we have understood. Let's look at what is a perfect number. A positive number that is equal to the sum of its distinct proper factors. Proper factors means factors other than the number are known as proper factors, is a perfect number. For example, if you look at the case of 6, 6 can be represented as 1 plus 2 plus 3. So 1 is a factor of 6, 2 is a factor of 6, 3 is a factor of 6. If you add up its distinct proper factors, they add up to give you a number itself. That kind of a number is known as a perfect number. Let's look at the next, which is 28. So what are the factors? 1, 2, then if you look at it, the other factor would be 4, then 7, then 14 and 28. So if you add all the factors apart from the number, so if you just look at it, 14, 7, if you just add these things up, 4, 6, 7. So this is 7 and 7 and 14. This is 28. Such kind of a number is known as perfect number. Now, if you have to write down a perfect number would be of the form 2 raised to power n minus 1 into 2n minus 1, where n is a positive integer that we have. So if you look at it, 2, I'll assume n as 3. 2 cube minus 1 into 2 cube minus 1. So this will be 2 raised to power 2 square, which is 4, into 7. What I got is 28, which is the second. If you assume the value of n to be 2, you will be getting 2 raised to power 2 minus 1 into 2 square minus 1. So this will be 2 into 3. You will be getting the first perfect number, which is 6. So 6, 28, 4, 9, 6. These are the examples that we have for a perfect number. Let's now look at an example. The question that we have is, the sum of 4 consecutive 2-digit odd numbers when divided by 10 becomes a perfect square. Which of the following can be one of those 4 numbers? Now I can start the question with supposing that the first number is x. Then the other number would be a consecutive number. Consecutive means x plus 2. The third would be x plus 4. The fourth would be x plus 6. This will be the sum of 4 consecutive 2-digit odd numbers. I have supposed x to be a 2-digit odd number. Now the question says, when this is divided by 10, the result is a perfect square. So if I look at it, my numerator become 4x plus 12 over 10 is a perfect square. Now I can keep putting in the values of x. If I take the value of x as 2, so if I take the value of x as 2, the number that I would get would be 8 plus 12, which is 20 by 2. The number that I get, y, which is a perfect square, y comes out to be 2, which cannot be my answer. Reason being, if you look here, this y equals to 2 is not a perfect square. So let's go ahead and let's look at the various other values of x that you can have. Now if I look at the next value of y that I will have, the next value of x that I'll have, if you put x is equal to 3, it is coming out to be 12 plus 12. Put x is equal to 4, it is 16. Put x is equal to 5, you have 20. 20 plus 2, again it is not divisible by 10 to give you a perfect square. So you keep on putting in the values of x, or if you know the concepts of geometry, you can form it into an equation and write down the equation like this. So x and y would increase or decrease with the coefficient of other variable. So once I've found out the value of x, the first value of x, the next value of x would be found out by looking at the coefficient of the other variable in the simplest term. Now here it is not in the simplest term because I can take 2 common and cancel it out. So if I'll take 2 common, it will be 2x minus 5y plus 6 is equal to 0. So now x will increase with 5 and y will increase with 2. So if I make the value of x as now increase with 5, so if I make it 7. 7 into 4, 28. 7 into 4 that I have is 28 plus 12, which is 40, over 10, which gives me an answer of y is equal to 4. So that is one of the perfect square that I have. So if I look at the option that I'll get, it will be 7, 9, 11 and 13. If I add all of them up, the sum adds up to 40 divided by 4 would give me a value of 10. But out of the numbers that are given here, none of the number matches. So I'll move ahead and I'll look at the next value of x. The next value of x would be again plus 5. so which comes out to be 12. Now if you solve for y at the value of x is equal to 12, your y would turn out to be 12 into 4, 48 plus 2, it turns out to be 6, which is not a perfect square. So I'll again move and look at the next value of x that will have. It will be 17. At this value, the value of the value of y that will come out to be is coming out to be, if you look at it, 17 into 4 plus 12 by 6. Plus 12 by 10. That is the value of y which is coming out to be, again, which is not a perfect square that I have. So if I keep on moving with the values of x and subsequently calculating for the values of y, I will get to my answer, which will tell me out of the following values that I'll have, which of the value satisfies for this thing. So if I just keep on doing this, I'll give you the time to do that. So you keep on doing your things and I will look at the value. Now look at it. Your x is somewhere that you have 21, 25, 41, 67 and 73. So taking in these small values of x would not help you out. I would just understand that x would be 7, then it will be 12, then it will be 17, then it will be 22, then it will be 27, then it will be 32, it will be 37, then the value that I'll get would be 42, 47 and so on. So these will be the set of values that I'll keep on getting. So if I just look at it, if I'll start with this 22, this cannot be my answer because this will be an even answer that I have, and x is given to me as odd. Again, this 32, this 42 cannot be the answers. The only answers that I'll be left with is 27, 37, 47, 57 and so on. Now if you look at consecutive numbers, when I start with 27, it will be 27, 29, 31 and 33. These will be the 4 consecutive numbers that I have. None of them is an option, so I will not proceed ahead with them. 37. So the numbers would be 37, 39, 41 and 43. These are the 4 set of numbers that I have. Now out of this, 41 is there in the option that I have. So what I'll do is, I'll just hold here. I'll add the values. Now if I look at it, the values that I need to add up are 37, 39, 41 and 43. They are in AP. The middle term will be like the mean of this. So 40. Every value can be taken as 40 into 4 values. That means what is it coming out to be? 160 divided by 10. What I have the value as 16, which is a perfect square. That means 41 is the answer that I have. This question involves the knowledge of algebra as well. So let's move ahead and let's look at the BODMAS rule that we have. BODMAS, as the rule suggests, first that we'll have to do is work with the brackets. Open up the brackets, then follow the operator which involves division followed by multiplication, addition and subtraction. So if a certain expression is given to me, and in order to solve that, I will first open up the brackets followed by division, multiplication, addition and subtraction. I will always do the stuff in this order. I will not do addition and subtraction first and then multiplication. I will always divide and multiply first, then move ahead and proceed with addition and subtraction. Reversing a 2-digit number. If we reverse a 2-digit natural number, the difference between the original and the resulting number will be equal to 9 times the difference between the tens place digit and the units place digit. So whenever you have to write a number xy, the number is always written as the digit into its place value. So this is 1's place digit, this is 10's place digit. I will always write the digit, what I have, into the place value. So number is always written as 10x plus y. When you reverse the digit, it will become yx. So the number would always be written as, again, the digit into the place value 10y minus x. when you subtract the number and the number formed by reversing the digits, you would look at whatever is the digit value of tens, whatever is the digit value of units digit, that will become for tens, and the tens becomes the unit, but their difference when you take, and if you take common thing, comes out to be 9 times the difference between the tens place and the units place. So this is the number, original one, this is the number formed by reversing the digits. The difference of their digit multiplied by 9 is the value that is obtained by subtracting both of them. Likewise, if you add them, so the original number that you have is 10x plus y. The new number that you get is 10y plus x. If you add both the numbers, the final number that you get is 11 times the sum of the digit at the tens place and at the units place. So for example, take the number 72. So the number would be written as, if you look at 70 plus 2, number formed by reversing the digits is 27, which is written as 20 plus 7. If you look at the difference between them, the difference between them would be equal to the 9 times the difference between the difference of the digit. So difference of the digit is coming out to be, if you look at 7 minus 2 is 5. 5 into 9. So the difference that you get is coming out to be 45. Even if you solve it out, the difference comes out to be 45. If you add up the two digits, so you get 99, which is 9 into 7 plus 2. So 9 times the sum, 9 times the, 11 times, it is 11 times the sum of the digit, 11 times the sum of the digits, which is giving you an answer. So difference is 9 times the difference of the digits, and sum is 11 times the sum of the digits at the tens place and at the units place. Reversing a 3-digit number. If we reverse any 3-digit natural number, the difference between the original and the resulting number will be 99 times the difference between the hundreds place digit and the units place digit. Similarly, if I have xyz, I will write the number as 100x plus 10y plus z. I am multiplying the digit with the place value. So a number formed by reversing the digits. Reversing, I always write the number from back to front. It will be z, y and x. Will be 100z plus 10y plus x. Now if I subtract both the numbers, the number which will be left will be 100x plus z minus 100z minus x. The y thing, which is the tens place digit, is the number which is getting cancelled out in both the scenarios. So the number which is formed is the difference, is 99 times the difference of the hundreds place digit and the units place digit. Let's take an example if you want. Let's take a number which is 913. Now if you take the reciprocal, the number becomes 319. Now if you subtract these two numbers that you have, you look at it that whatever is the difference between 9 and 3, 99 times the difference of 9 and 3, so which is 99 into 6, will be the answer when you subtract the two numbers that are given to you in the question. I hope the concept is clear to you. This is a very simple thing that we have. Let's move ahead and let's look at divisibility rules. Divisibility rules is the way of determining whether a given number is divisible by a divisor without actually performing the division. Usually it is done by just examining the digits of the given number. So divisibility rule is a very easy way out to find whether a given number is divisible by a divisor or not, rather than wasting time in actual calculation. Divisibility rules also help us in finding the remainder if the divisor is not divisible by a given number. If the divisor is divisible by a number, the remainder would have been 0. If it is not divisible, the remainder would be obtained by applying the divisibility rule. So let's look at the common divisibility rules that we have. If I have to check the divisibility by 2, I would look at the last digit of the given number. The last digit should be divisible by 2 or could be 0. So I will only look at the last digit. I will not look at the rest part of the number. If the last digit is divisible by 2, that means it's a multiple of 2. It should be 2, 4, 6 or 8 or should be 0. A number is said to be divisible by 2. All the numbers which are powers of 2 will follow the similar divisibility rules. So if I look at the next power of 2, which is 2 square, which is 4. So if I just go about 4 and look at and extend the similar divisibility rule, I would look at the last 2 digits. Instead of a last digit, I would look at last 2 digits. Last 2 digit should be divisible by 4 or should be 00. Similarly, if I have to check the divisibility by 8, which is what? 2 cube, this is with 2, this is with 2 square and this is with 2 cube. I will look at the last 3 digits. Since the power is 3, I will look at the last 3 digits and I will not look at the rest part of the number. If the last 3 digits are divisible by 8 or 000, the number is divisible by 8. I would only look at the last 3 digits. Let's move ahead. Let's look at the case of 3. So to check the divisibility with 3, I will sum up all the digits of the number. This is not the digit sum. Digit sum is a single number. What I'm just doing is plain sum of digits. If the sum of digits is divisible by 3, the number is also divisible by 3. So I would only look at the sum of digits and check its divisibility with 3. Any power of 3 would follow a similar rule. So I look at 3 square, which is 9. So if I look at 3 square, which is 9, so I would check that 3 square, I would again do the sum of all the digits and the digit sum should be, the sum of digits should be divisible by 9. If the sum of digits is divisible by 9, the number is divisible by 9. Let's look at the case of 5. Last digit should either be divisible by 5 or should be 0. So I will look at only the last digit. Last digit should be divisible by 5 or should be 0. The entire number is divisible by 5. Any power of 5 would follow a similar divisibility rule. So if I check the divisibility with 5 square or with 25, I would look at last 2 digits. The last 2 digits should be divisible by 25 or should be 00. So if I know the basic divisibility rules, I can extend it to the powers. Let's move ahead and let's look at the divisibility rule of 6. So to identify whether a given number is divisible by 6 or not, I would split it up into two prime numbers 2 and 3. Because 6 is a composite number that I have. The number should be divisible by 2 and by 3 to be divisible by 6. If a number is only divisible by 2 but not 3, it is not divisible by 6. Divisibility with 10, the last digit should be 0. Most important is your divisibility with 11. To check the divisibility with 11, I will divide the number into two series of alternate digits. The difference of the two series of alternate digit, I am talking about the difference in the sum. I am talking about the difference in the sum of the two series should either be 0 or a multiple of 11. So the difference that you are getting in the two series sum should either be 0 or a multiple of 11 for the number to be divisible by 11. So for example, I take the number as 1. I take the number as 1, 3, 3, 1, 7, 2, 9. So I look at the two series that I get, 9, 7, 3, and the second series will be 2, 1. I'll just remove this 3 from here. 2, 1 and 1. So if I just look at it, 9 plus 7 plus 3. So this gives me 19. 2, 1 and 1. This is 4. Now if I look at the difference between 19 and 4, it comes out to be 15. Since 15 is not a multiple of 11, the entire number 131729 will not be a multiple of 11. Let's look at another number, 1331. So I'll get two series, 1, 3 and 1, 3. This sum is 4, this sum is 4. If I find out the difference between the two series sum, that is coming out to be 0. So that means this number is divisible by 11. Let's look at the case of 12. 12 again is not a prime number, so we'll break it into two factors such that the two factors that you have are coprime to each other. Since 4 and 3 are coprime to each other, I would check the divisibility with 4 and with 3. So the number has to be divisible by 4 and by 3 for it to be divisible by 12. Now if a number is divisible by any divisor, the remainder would be 0. If the number is not divisible by the divisor, there would be a certain remainder. The divisibility rules also help us to find out the remainders. For example, I have to check the number. Let me take an example that we have the number 52 and check the divisibility with 3. Now if I do the sum of the digits, it is coming out to be 7. Since 7 is not divisible by 3, 52 is not divisible by 3. Whatsoever is the remainder that 7 gives with 3 will be the same remainder that 52 would also give with 3. So 7 divided by 3 gives a remainder of 1. 52 when divided by 3 would also give a remainder of 1. So divisibility rules also help us in finding out the remainders. Let's move ahead and let's look at the divisibility with 7, 13, 17 and 19. Now these are the divisibility rules that you could choose to remember. However, even if you don't remember them, you can do a normal division. So if I have to check the divisibility with 7, what I'll do, I'll double the last digit. So whatever is the number that I have, I'll separate the last digit, double it, subtract it from the remaining leaded truncated number. If the result that I got is divisible by 7, then the original number is divisible. Apply this rule over and over as required. So for example, if I have the number which is 521, what I'll do, I'll remove this number. I'll double it. So I get 2. From the remaining part of the number, I'll subtract 2. The number that I get is 50. Is 50 divisible by 7? No. That means this number 521 is also not divisible by 7. So look at another number 323. Remove this part of the number, double it. Subtract it from the leftover number that you have. What are you left with? 26. Is 26 divisible by 7? No. That means this number is not divisible by 7. Similarly, if I have to check the divisibility rule with 13, I will again separate the last digit. I will multiply it with 4 and I will add it. Instead of subtracting it, I will add it to the remaining leading truncated number. If the result is divisible by 13, then the original number is divisible. Apply this rule over and over as required. That means if the number is a large number that I have, I can apply this rule over and over again till the time I get a 3-digit or a 2-digit number, which I can easily identify being a multiple of 13 or not. To check the divisibility with 17, I will again look at the last digit, multiply it with 5, subtract it from the remaining number. If the result is divisible by 17, then the original number is divisible by 17. If the result is not divisible by 17, the original number is also not divisible by 17. So it's a similar rule. What you just have to do is take out the last number, double it and add it in the case of, double it and subtract it in the case of 7, 4 times and add it in the case of 13, 5 times and subtract it in the case of 17, double and add it in the case of 19. So what you do is you keep on doing these things till the time you get a result which is divisible by 7, 13, 17 or 19 as required. Let's move ahead and let's look at the concept of factors. Factor of a number are a set of numbers which are less than or equal to the given number which divides the given number completely. Completely means there's no remainder which is left out. So factors are defined as the set of numbers less than or equal to a given number which is dividing the given number completely. So let's look at a number 6. Lesser than 6, there are numbers like 1, 2, 3 and 6 which divide 6 completely. So 6 is divisible by 2, 6 is divisible by 3, 6 is divisible by 6. So these numbers do not leave a remainder. These 4 numbers that you have are known as factors of 6. Factors are the numbers you multiply together to get the required number. So if I have to look at 6, it will be what? 1 into 6 which is 6 and 2 into 3 which is 6. So you are multiplying the two factors together to get to the original number. The number of factors are always countable. You can always count the number of factors. The smallest factor would be 1. So if I look at 1, 1 is a factor of every number because every number is divisible by 1. Factor of every number. Then n, which is the number itself, is the highest factor. So all the other factors would be between 1 and the number itself. So if I look at the case of 12, I would look at certain things like 2 into 6 is 12, 3 into 4 is also 12 and 1 into 12 is also 12. So all the numbers like 1 starting with 1, 2, 3, 4, 6 and 12 are the factors of 12. So always I can count the number of factors of a given number. The smallest factor is 1. The highest factor is the number itself. So we have already counted the factors of 12. Also minus 1, minus 2, minus 3, minus 4, minus 6, minus 12 are also factors of 12 because when you multiply two such negatives, you get 12. So minus 1 into minus 12, minus 2 into minus 6, minus 3 into minus 4 would also give you factors. But generally, we take the factors as positive. We consider factors as a set of natural numbers. However, you can always, this thing can also be done. Fractions are usually positive, but I can write them as negative whole numbers as well. And there are no fractions that I have for factors. Factors of a number cannot be in fractions. So if I look at again the factors of 12, the factors of 12 were 1, 2, 3, 4, 6 and 12. So there are 6 factors that I have for 12. Now if I write them in an increasing order, I would look at the first and the last would be multiplied to give you the number. The second and the second last will be multiplied to give you a number. The third and the third last would multiply to give you the number. So if I look at equidistant factors, their product will always be equal to the number itself. So the number of factors comes out to be 6. There will be 3 pairs that you will have that will give you the product of factors as the number itself. So it is basically half the number of factors. The number of pairs would be half the number of factors that we'll have. Product of equidistant factor would give you the number itself. Now let's calculate the number of factors that we can have for a given number. There are certain steps involved in calculating the number of factors. The first step would be write down the number in a prime factorization form. So let's take with the help of an example. I give you a number which is 36. So what I have to do is I'll have to write 36 in a prime factorization form. How will you do it? I hope you know this thing. But when I'll divide it with 2, I'll get 18. Again divide it with 2, you'll get 9. Divide 9 with 3, you'll be left with 3, and again 3 with 3, you'll get 1. So basically it is 2 into 2 into 3 into 3, which can be combined as 2 square into 3 square. Here A, B, C are the prime factors that we have. If you look at 2 and 3 are the prime factors raised to some power. So these are the powers that we have. So this is the first step that I need to do when I am writing out factors of any number. The second step would be, and the second step would give me the answer, the number of positive factors. Now this formula give me only the positive factors, including 1 and the number itself, would be given by the powers that I have is what I need to focus on. This power is 2, 2 plus 1. Increment the power with 1 and multiply them. 2 again, 2 plus 1. So this will be 3 into 3, giving me an answer of 9. So it will be P plus 1 into Q plus 1 into R plus 1, so on up to K plus 1. So I will increment the powers with 1 and I'll multiply them. That will give me the number of positive factors. Now this number would include the case of 1 and the number itself. So it will include 1 and the number itself and the number. Now for example, if you have n as 441, 441 can be written as 3 square into 7 square. So the number of factors would be 2 plus 1 into 2 plus 1, which will be 3 into 3, giving you an answer of 9. Now if you look here, the number of factors that are coming out to be odd. Number of factors are coming out to be odd. That means the numbers that I have taken are perfect square. So if I write down the factors of 36, there will be 1, 2, 3, 4, 6, 9, 12, 18 and 36. So 1 into 36 gives you 36, 2 into 18 gives you 36, 3 into 12 gives you 36, 4 into 9 gives you 36 and 6 square gives you 36. So if the number that I give you is not a perfect square, let me talk about 72. It is what? 2 cube into 3 square. The number of factors would be given by, this is 2 cube into 3 square, 3 plus 1, 4 into 2 plus 1, 3. It will be given as 12, which will be even. So the number of factors for a perfect square are always odd. Another number that I take, 360, again is written as in the prime factorization form, 2 cube, 3 square and 5 raised to power 1. So the number of factors would be 3 plus 1 into 2 plus 1 into 1 plus 1. So giving me an answer of 4 into 3 into 2, 24. So there are 24 positive factors, including 1 and the number itself. Including everything, there are 24 positive factors that I have. Let's move ahead and understand how to calculate the sum of factors. Now we have already calculated the number of factors, so I have to sum all of them up. Like for example, the factors of 36 were 1, 2, 3, 4 and so on. I'll add up all the factors, that what will be the answer that I'll have to this question. In case the number is very small and the number of factors are coming out to be small enough, you can always add the factors and get to your answer. But in case the number is big enough and there are too many factors for the number, it's very difficult for you to actually find the factors and sum them up. So we follow the formula. The formula is the same steps that you have to do. Write the number in the prime factorization form as done while finding the number of factors, and use the formula for the sum of a GP to find out your required answer. Now, if let's say, I'm again talking about the number 36. 36 would be 2 square into 3 square. That means the highest power of 2 is 2. That means it is divisible by any powers of 2 less than 2. That means it is divisible by 2 0, 2 1, 2 2. It is divisible by 3 0, 3 raised to power 0, 3 raised to power 1 and 3 raised to power 2. So these are all the factors that you will have. What I do is I sum up these factors, and then I multiply them to get to the total sum of the factors that can be obtained. So it is 2 raised to power 0 plus 2 raised to power 1 plus 2 square into 3 raised to power 0 plus 3 raised to power 1 plus 3 square. 4, 6, 7. This is 7, 9, 12 and 13. So 13 into 17 would give me the sum of all the factors of 36, which adds up to give you an answer of 91. This formula is the formula for the sum of GP. A raised to power P plus 1. So what is the form that I've written? I've written in the form ABC raised to powers PQR. A raised to power P plus 1 minus 1 over A minus B raised to power Q plus 1 minus 1 over B minus 1. C raised to power R plus 1 minus 1 over C minus 1. Now, the next thing is number of coprime factors. Factors which have an HCF of 1 are known as coprime factors. Now, obviously, I am not looking at one factor. I am looking at a pair of factors or 3 or 4 factors at the time so that I can look up and find their HCF. So, if the number that I give you is 60, which can be written as 2 square into 5 into 3. I can find out the number of factors which will be given by 2 plus 1 into 1 plus 1 into 1 plus 1, which is coming out to be 12. Now, these factors, if I write them down, are 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30 and 60. The product of equidistant factor would give you the number itself. So 2 into 30, 3 into 20, 4 into 15, 5 into 12 and 6 into 10. You can also look at the number of factors are even. That means it is not a perfect square. Now, if you look at it, 60 can be written as a product of its two factors in 6 ways. What are these 6 ways? 1 into 60, 2 into 30, 3 into 20, 4 into 15, 5 into 12, 6 into 10. So whatever is the value for number of factors, divide this with 2, you will get the pairs. You will get the pair of factors which when multiplied give you the product of 60. Now out of these pairs, certain pairs have an HCF of 1. Those pairs are known as pair of coprime factors. So 60 and 1 have an HCF of 1. 2 and 30 do not have HCF of 1, they have an HCF of 2. 3 and 20 have an HCF of 1. 4 and 15 have an HCF of 1. 5 and 12 have an HCF of 1. 6 and 10 have an HCF of 2. Now all these 4 pairs will be known as coprime factors, and 60 can be written as a product of its two coprime factors in 4 ways. If you want to remember an easy formula, the formula is 2 raised to power m minus 1. Now what is m here? M are the number of prime factors of this number. It is the number. So if you look at how many prime factors are there, it is written as 2 square, 5 raised to power 1. So number of prime factors are 1, 2, 3. 2 cube minus 1, which is giving you an answer for 4 factors. So there are 4 ways in which 60 can be written as a product of its 2 coprime factors. Now the next concept that we need to understand is highest common factor. As the name suggests, you find the factors, look at the common factors and look at the highest among the common factors. So the largest number that divides the 2 or more given numbers is known as the highest common factor. It's the highest common number that can divide both the numbers simultaneously. To find the HCF of the given numbers, perform the prime factorization of all the numbers and then check for common factor. Once you understood the common factors, look at the highest common factor. Let's look at the numbers 72, 288 and 1080. I have to find the HCF of these numbers. So 72 can be written as 2 cube into 3 square. 288, the prime factorization form is 2 raised to power 5 and 3 square. 1080, the prime factorization form is 2 cube, 3 cube and 5. So I will look at the common factors and I will look at the highest common factors. So 2 is coming out to be 3 times in minimum all of them. What about 3? 3 square, 3 square, 3 cube. So the common factor that will be highest would be 3 square, which will give me an answer which is 72. HCF is given by the lowest indices of the common prime factor. Lowest, why? Because it has to be common in all the 3. So whatever is the minimum would be the common. HCF is also known as GCD, greatest common divisor. Let's look at LCM now. LCM, as the name suggests, is the lowest common multiple. Multiple of a number is greater than that given numbers. So LCM of 2 or more numbers is the lowest number which is divisible by all the given numbers. So with all the given numbers, I find out a number which is divisible by each one of which is divisible by each of the numbers given. So after performing the prime factorization of the numbers, we find out the highest index among the given of all the prime factors. In case of HCF, we look at the lowest index, and in case of LCM, we look at the highest index that is there for all the prime factors. So the LCM is the product of all of these prime numbers with their respective highest indices, whereas the HCF was the product of these prime numbers with their lowest indices. So LCM of 72, 288 and 1080 would be, it's the same example that we have done. So 72 would be written as 2 cube into 3 square, 288 would be written as 2 raised to power 5 into 3 square, 1080 would be written as 2 cube into 3 cube into 5. Now if I have to look at the LCM, I would look at this 2 and the highest power, which is 5. I would look at this 3 and the highest power, which is 3. I would look at 5. 5 is only there 1, so I will take it 1. So it will be 2 raised to power 5 into 3 cube into 5, which will be 4320. Now 4320 is the smallest number which is divisible by 72 and 288 and 1080. The next such number would be double of this, which will be 8640. That will be the second number which is divisible by all 3 of them simultaneously. Okay. So let's take two numbers A and B. LCM of A and B into HCF of A and B would be equal to the product of the two numbers. So this is valid for two numbers only. For two numbers, the product of LCM and HCF is equal to the product of the two numbers that you have. So example, let's A is equal to 120. I've done a prime factorization for this. B is equal to 18. I've again done a prime factorization for this. So LCM, I will take 2 cube, I will take 3 square, and I'll take 5. HCF would be 2 and 3. 2 into 3, which will be 6. Now if I look at it, the product of LCM and HCF in this case is coming out to be equal to the product of the two numbers. This is a very, very important relationship that we have when we are talking about this thing. Now an important thing that you have to keep in your mind is it is applicable for two numbers only, not for three or more numbers. Another thing that you need to look at, if you know HCF, both the numbers will always be the multiples of HCF. So this will be some multiple of HCF, this will be another multiple of HCF, and LCM is also a multiple of HCF. Both the numbers and LCM are always the multiples of HCF. Look at some of the properties of HCF and LCM. The HCF of two or more numbers is smaller than or equal to the smallest of those numbers. So whatever is the smallest of the two numbers, the HCF would be smaller than or equal to that. Whereas the LCM of the two numbers is greater than or equal to the largest of the two numbers. So whatever are the largest of the two numbers, that will give me the minimum value of LCM. Whatever is the smaller of the two numbers, that will give me the maximum value of HCF. If HCF of numbers n1 and n2 is k, then n1 and n2 are always multiples of k. So both the numbers are multiples of their HCF. Since HCF divides all the numbers, both the numbers are multiples of HCF. That is what you need to understand. If HCF of two numbers n1 and n2 is k, then if I add up the numbers or if I subtract the numbers, still they are divisible by k. If the HCF of two numbers is k, that means the first number would be k times x and the second number would be k times y. This will be kx plus ky. You can take common, this will be x plus y. Again here you take common, this will be x minus y. So even if you add both the numbers or subtract both the numbers, they are still divisible by k. If L is the LCM of four numbers n1, n2, n3, n4, then all the multiples of L is the smallest number, all the multiples of L would also be divisible by n1, n2, n3 and n4. If a number n always leaves a remainder of r when divided by numbers p1, p2, p3. So what is there? If n is divided by p1, the remainder is r. If n is then divided by p2, the remainder is r. If n is divided by p3, the remainder is r. Then the smallest value of such n would be given by LCM of p1, p2, p3. Now LCM would give me the smallest number which is divisible by p1 and p2 and p3. That means it gives a remainder of 0. Now what is the remainder that I want? Certain r. To this I add r. So it will be LCM or a multiple, because I am looking at the second highest number or the third number that is giving me such things. So it will be LCM of the divisors, which will be p1, p2, p3 plus a common remainder. This number would give me a remainder of 0 and added to a common remainder would give me my answer. Now in order to find LCM of fractions, I will divide it into numerators and denominators. If I club the numerators and find out their LCM and write it in the numerator, I'll club all the denominators, find out their HCF and write it in the denominator. That will be the LCM of fractions. So for example, let's look at 3 by 7, 6 by 7 and I have 5 by 4. If I have to find their LCM, LCM would be given by LCM of numerators. What are the numerators? 3, 6 and 5. And HCF of denominators. What is the denominator that you have? 7, 7 and 4. So if you look at the LCM, 3 and 6, the LCM is 6, 6 and 5, nothing in common. So the LCM would be 30. 7, 7 and 4, 7 and 4, nothing common. So the LCM of these fractions comes out to be 30. It is LCM of numerators divided by HCF of denominators. Similarly, if you have to find out HCF of fractions, it will be HCF of numerators and LCM of denominators. So if I just look back and take the same values, you're looking 3 by 7, 6 by 7 and 5 by 4. Now what I have to do is I have to find their HCF. It is HCF of the numerators. What is it? 3, 6 and 5 followed by LCM of denominators, which is 7, 7 and 4. So 3 and 6 have 3 in common, 6 and 5 have nothing in common. My HCF would be 1 divided by my LCM, which is 28. So this will be the answer for HCF. So let's look at some of the questions on LCM that we have. Find the highest 3-digit number that is divisible by each of these numbers: 12, 12, 36, 60 and 90. So let's look at some of the questions on LCM. The first question that we look at is find the highest 3-digit number that is divisible by each of the numbers 12, 36, 60 and 90. So I want a number which is divisible by 12 and 36 and 60 and 90. So basically what I am looking at is the common multiples of 12, 36, 60 and 90. Common multiples. So if I just look at it, 12 can be written as 2 square into 3. 36 can be written as 2 square into 3 square. 60, 2 square, 3 and 5. 90, 2, 3 square and 5. So I will look at the LCM. If you look at the powers of 2, it is 2 square, it is 2 square, it is 2 square and 2. I'll keep the highest one, which is 2 square. If you look at 3, it is 1 here, it is 2 here, it is 1 here, it is 2 here. I'll keep the highest one, which is 2. Now if you look at what are the other powers that you have for 5, it is 1, so I'll keep 5 and the number that I've got is 180. So this is the LCM. This is not the highest 3-digit number, this is the smallest 3-digit number that I have. So if I have to find out the highest 3-digit number, it will be multiple of 180. So if I keep on multiplying 180, if I multiply 180 with 5, the number that I get is 900. The next multiple would be 10. It will be greater than 1000. It will not be a 3-digit number. So my answer for this will be 900. The other way that I can do is I look at the highest 3-digit number. What is it? 999. 999 when divided by 180 gives a remainder of 999. So subtract that 999. I'll get 900. Or what you do is just look at the multiples of 180 below 1000. That will give you your answer. Let's look at the next question. The question is find the smallest number which gives a remainder of 5 when divided by any of the numbers 6, 7 and 10. So what is it? This 5 that I have is a common remainder. That means a number which gives a common remainder. Now to find this thing out, I always first find out the number which gives a remainder of 0. So if I look at 6, 7 and 10, it will give me a remainder of 0. So if you look at it, 6, 7 and 10 gives you an LCM of 210. This 210 is divisible by 6, 7 and 10. That means it gives a remainder of 0. Now what is the common remainder that I want? 5. So I add it up. The number that comes out to be is 215. 215 will give a remainder of 5 when divided by these 3 numbers.